Welcome everyone to this week one revision session. I am Suchit Sharma and I welcome you all to my YouTube channel. I do these revision session videos where we revise each and every week for a particular subject for IIT Madras BS degree course. We have done multiple sessions before, but on high demand I have to record these sessions for the people who are unfortunate enough to not join the Gmeet link on time. So let's start with our session and let me introduce you to our way of studying. Okay, so this is what the page for once you enter this is what the page looks like once you enter into the D.B.M.S subject. We have various weeks. We have data released for week 7, but since I have starting this whole session from the start, I have to start from week 1, although we have covered till week 4 for quiz 2. How do we study? We study through these supplementary content lecture slides that are being provided on here. As you can see, once you click here, you would be redirected to this page. The page should look something like this. And let's go into week 1. We have 5 lectures here, which we would be covering in, I guess, the next hour or two. I guess it would take an hour or two. You can watch the video at 2x speed. For my southern viewers, I am doing this session in English because most of the people cannot understand Hindi. However, it would be really better if I could use Hindi as it's my mother tongue. So let's leave it at that. Okay. My methodology of learning a particular subject is watching each and every lecture. Once I have completed the lecture, I go to lecture slides in PPT. I also do make notes, but for the sake of convenience, I'm using the PPT slides provided here. This is the week 1.1 slide that's being provided by the institute. We go through each and every PPT for the given week. We read and understand the PPT, which takes around 15 minutes. Then we solve the activity questions, that is, you know, the activity question in, in accordance to the specific video. Let me just remove each and every, I guess, since we have solved this once, I have to remove that. Let's put it here, right? Let's keep it here. There would be some mistakes here, but let's ignore them. I I don't think I can unselect it, right? Or can I? Can I unselect it? No, there is no way of Okay, let's leave it at a. So this is week 1.1. This week, this video lecture has no activity questions, associated with it. But since they have provided it, we have to complete it, right? So we also have to thank Dr. Parth Pratham Das, who designed this beautiful course and taught us the course. I would also like to thank Indian Institute of Technology, uh, actually Madras. He is from Kharagpur, but I would have to thank my particular institute. So each and every the data provided, the PPT provided, the activity questions provided are the property of IIT Madras, and I have no ownership of the content that I am providing you, except my voice and my explanation. So let's start. In this module, we would learn why do we use database and what is KYC. Okay, so KYC, course prerequisites, course outline text post textbook. Okay, okay. Let me check one thing, one a single thing that am I live or not. Let me check whether I'm live or not. Okay, so I am live. Okay, so we are live, and the video quality and audio quality is also really good. Let's start. Why? So the initial question that comes to our mind is why database, right? Why do we need database, right? So each and every enterprise has data, right? Let's say you have a small dukan, perchun ki dukan. You sell cosmetics. You have you sell pens. You sell various types of material, stationery, some kirana. Now you have to keep data, right? You have to store data that how much do you have in stock, how much have you sold, how much do you need to buy, is there a specific festival coming or not. This actually really facilitates the business aspect of any enterprise that you go in, right? Now DBMS is collection of interrelated data. DBMS has specific programs to access a given data. The data given in DBMS is basically tables. Okay, you have tables. That's it. Tables and DBMS go side by side. An environment that is both convenient and efficient to use. I would be just speeding through this because this is just you know rectification material. Again, where does database have application, banking, airline, university, sales, manufacturing, online, retailers, human resources. So each and every field has the use of database. Databases are really really large and touch all aspect of our life. Okay, let's university database sample. Let's leave this. Okay, data redundancy and inconsistency, accessing data, data isolation, integrity problems. Okay, this is important. Data integrity problem. Integrity constraints become buried in a program rather than being stated explicitly. Okay, hard to add new constraint or change existing one. Okay, so this topic, drawbacks of file system to store data, is really important. As I since I've completed the week once before, I can tell you that this is a really important topic. What are the problem of file system? uh, the term before this, when you were or in the foundation term, let's say you are taking DBMS in some other term rather than just taking directly after completing your foundation. So in foundation level, you might have used or you might be really you might remember file systems from Python, the file handling problems, writing into file, reading into file, appending file and all. So now, what is data redundancy, data inconsistency? There is really inconsistent data in file system. There is no particular order. Let me show you one text file. If I can, is there a text file here available on my PC? It's a text file, right? Textbook. Let's go to a textbook. That would be really easy for you know teaching you. Okay, NCRT. I guess each and every one of us has heard of NCRT once in their lifetime. Select class, any random class. Select subjects, social science. I guess science. Textbook title. I guess science. Go, right. So what file systems? How file system saves data is in this way. It would just take data and store it line after line on top of each other. So it's really really hard to access a particular data. Let's say this is the given data, right? So what would you do if I ask you to remove this word or add something here? There's no meaning of the data, right? And as I just said, there is difficulty in accessing data, because how can you define a specific word? Let's say lactic acid, you would have to define like a word on the right of accumulation, a word on the left of causes, a word that is in 1, 2, 3, 4, 5, 6, sixth line. It would be really hard to tell a PC how to reach a particular word, right? There are multiple files and multiple formats, which is really hard to work on through file systems. There are some more drawbacks of file system, one of which is atomicity of updates. Failure, let's say you are running a code and there are failures, right? So failure may leave database inconsistent state and partial updates carried out. So let's say I asked you to change, or let's say I asked you to change the color of this much into red, right? But there was some failure that came somewhere around cramps, the word cramps. So what would happen is, from have till from the words would get colored red, but the rest of the words won't. That is a problem if failure occurs. Like, example is transfer of funds from one account to another should either complete or not happen at all. It shouldn't be like, oh, let's say I am transferring 10,000 rupees from my HDFC account to my SBI account. It shouldn't happen that 5,000, let's say I am transferring 10,000. It should happen that okay, 5,000 is sent, but there was an error while sending the other 5,000. That should not occur. That once I check my SBI account, I see, oh, 5,000 has reached. Where are the rest of the 5,000? And I would have to reach out to banks again and again. Concurrent access by multiple users. Okay, there is inconsistency in file system, as everyone has ultimate access over each and every aspect of the file. Anyone can access anything. Okay, there are security problems, like hard to provide users access to some but not all. So let's say there's a table containing name, dates, date of birth, and residence plus salary. So you do not want to show the salary column from a table, so you have to hide it. But in file system, there is no such way to do that. Once you open it, it would mhm, it would either show you this or nothing at all. Let's say I want only, like, just the thing that I'm doing here. This is the file, nah, this is the whole file, but I'm able to show you just this much words, right, by zooming in. But let's say there was no option to zoom in. How would you hide the data? How would you make this data relevant and hide this data? I think there is no other way. So this is actually not possible in file systems. Know your course. Okay, so you need to have a good grasp over set theory, De Morgan's law, subset, superset, power set, universal set. I think the main thing that you need, you know, mastery over is this much: operations on set. That is Cartesian product, difference, complement, intersection, and union. I think that's all you would need. They also ask us to complete this. If you want, you can do it. If you don't, I think people have completed this, right? Mathematics for data science one, each and every one of us done, as we are in diploma level. Okay, those prerequisites, essentials, binary. Okay, let's skip the prerequisites. Okay, so that was all that was given in. Why do we need dataset? How is it superior to file handling system that is available in Python? In the later weeks of Python, we are taught the file handling problems, right? I guess I need to plug in my charger. There is uh, low battery. Give me, excuse me, I just need a few minutes. Just 1 second. Okay. Okay, so my PC has started to charge. Good. Now we are diving into the actual content that is provided in week one. That is why D.B.M.S 1, why D.B.M.S 2. So it takes them two whole lecture to convince us why should we use D.B.M.S, right? Let's dive in it. Okay. The module outline is evolution. How did we? How did database management system came to be? And once it was invented, what is the history of DBMS? Once something starts, then obviously each and every second that it exists, it is writing its own history. So let's start. Evolution of database management system. Management of data or records is a basic need for human society. Audit, archival, basic stuff for individual, small to big enterprises or even global level. There have been two major approaches in this practice, that is physical and electronic, right? So let me emphasize on this one, right? This would be repeated many times in this PPT. The physical way being, writing into logbooks, you know, writing everything up in a book, on a paper, using pen, pencil, or anything that you are, comfortable with, or that is economically viable at that particular time in history. Recently, we got introduced to this electronic section too. That is the one on which DBMS is based on. Database management, physical, as I said, physical data or record management, formerly known as bookkeeping. So if you ask your parents or grandparents, they would know what bookkeeping is. You know, using physical ledgers or journals for centuries. Okay, most of the significant development happened when Henry Brown, American inventor, patented receptacle for storing and preserving papers. These people, man, everything they want patent over. Let's leave it. Let's leave it at that. Why? Why do you need patents over things? If you want to do it for humanity. Why this patent shit? And Herman Hollerith, Arnold Schwarzenegger. Okay, Herman Horleth adapted the punch cards used for weaving looms to act as memory for mechanical tabulating machine in 1890s. Okay, so should we see this one? Should we let's see a picture of it? Let's understand, because I guess this line is pretty beautiful. If you can skip a few minutes after this if you want to just read or understand what for quiz one, but I will be doing it the way I like. See this machine, I guess in olden movies I think you might have seen this. Look, it's tabulating data using using what was it that he used? Weaving looms for mechanical tabulation. Okay, is there a working video available on this? I guess there is. There is.
This is a mechanical jacquard loom. This technology was developed in France in 1803 by a weaver named Joseph Marie Jacquard. The key thing about this loom is that it controls every warp thread, the threads that go from the front to the back of the loom, individually. Because it can do that, the loom can create very complex, fancy patterns in the cloth more quickly and with greater accuracy than the technology available before this loom was developed. These cards are what carry the instructions that are read by the apparatus on the second floor that tells the loom what pattern to create. The holes in the cards are read by a series of pins up in the apparatus, and those holes tell the apparatus which threads down here should be raised for each pass of my shuttle across the warp. Some of you might recognize these cards as looking similar to computer punch cards. Back in the early days of computer technology, punch cards carried instructions that told the early computers what kind of calculations to do. So this loom is the great-great-great-grandfather of the computer technology that we all use today, and that technology started with a machine that produces cloth.
Shout out to the Henry Ford for providing this beautiful video. Please don't give me a copyright. Please don't give me a copyright. I thank you for your video. Please don't give me copyright. This is my first video. Okay, so let's move forward. Since we know what physical method of data management was, let's dive into electronic one, because once you go electronic, you evolve rapidly. So, oh, this is a really good thing that they taught us, that computer programming started in 1950s. That's like 70 years from now, 73 years from now. Then data management with punch card tapes, magnetic tapes. Okay, in 1970s, COBOL and Codacil approach was introduced in October 14. Blah blah blah. Magnetic discs became prevalent. I think I would really recommend you to watch video on how these 1960s machine worked. We were quite unfortunate that this beautiful technologies were not available in India back as we were developing. We were an underdeveloped country. Let's move forward. In 1980s, we got RDBMS that changed the face of data management. 1990s, internet was starting to boom. 2000, e-commerce boomed. This Facebook, Meta, Amazon, Google. It's really good that it's internet that enables us to do these sessions, to get a degree online. Now, in 2010s, we had data science that started riding high. That's the degree that we're doing. Electronic data management depends on various parameters. Okay, these are the parameters that are durability, scalability, security, retrieval, ease of use, consistency, efficiency, cost. Bookkeeping. I would skip this slide, and we'll come on it later on if the need be. Spreadsheet, a better solution. Let's okay. This is important. Okay, while you file system, see, they would continuously emphasize on leaving file system as if they are salesmen of D.B.M.S, but it is really important that you understand. I think there was a question in quiz 1 that asked why did we leave file system. Okay, so bookkeeping. Shop owners used to maintain their records. In a book register was maintained, on which shop owner wrote the amount received from customers, the amount due for any customers, in inventory details, and so on. Okay, so let's talk about problems, because we are focusing on DBMS. We definitely know there would be problems with any other form of data, data collecting or data management system. Physical damage to these resistors were a possibility due to rodents, humidity, and wear and tear. Coming to scalability, there is where it was very difficult to maintain it for many years. Like once you write in a book, every 10 years or so, you have to rewrite the whole book, because book is a natural enemy. It is a natural thing that will corrode or degrade over the years. Security, anyone can let's say you wrote 10 rupees as a ledger, or 10 rupees as the price to pay to someone. Someone can easily add another zero or a few more zeros. Time consuming. Okay, this was a really time consuming way. It took a good chunk of time to go use this method of data management. Obviously, any system that requires direct human contact is highly prone to human errors. Spreadsheet files, a better solution. Okay, so solution to bookkeeping was spreadsheet files. Just took my favorite drink, pani. Uh, Spreadsheet files, a better solution. Software like Google Sheet, okay, but I use Microsoft Touch, so I won't promote this. Due to this and due to the disadvantages of maintaining ledger registers, organizing, dealing with huge data, okay, people started shifting to spreadsheet softwares. That is what they are saying. Durability is data is less prone to physical damage. Okay. Scalability easier to search, insert, and modify into records as compared to book ledgers. Remember that. Security, you can always add, your birthday as a password, or just remember that password isn't a good password. The word password isn't a good password. Easy to use. Computer applications are used to search, manipulate, blah blah blah. Consistency not guaranteed. There is still no guarantee of consistency in spreadsheet, but spreadsheets are less prone to mistakes than registers. Okay, this line is, I guess, really important to throw on the face of someone who knows or does this, use a spreadsheet. It is only good for single user or small enterprises. Why leave file system? This. Uh, the limitations of pave the way for comprehensive. This line is more important here. The above limitations of file system paved the way for comprehensive platform dedicated to management of data, the database management systems. Wow! So we are finally, introduced to our course. Let's move forward. History of D.B.M.S. Okay, so we have invented D.B.M.S finally here on the slide, the 11th slide. Now let's start tapping into the history of database. I'm sorry if this gets boring to anyone, but this is what week one is all about. Okay, this is what week one is all about. Okay, uh, is there some way that I can hello hello hello? Okay, better. In 1950s, magnetic tapes were used, but the tapes only provided sequential data, used punch card for inputs. In late 1960s and early 1970s, hard disks allowed direct access to the data. Network and hierarchical data models in widespread use. Okay, now this line is important. IBM research begins system R prototype. UC Berkeley begins Ingress prototype. Okay, high performance for this for the right. Yes, yes, yes. Like they used like they used KB, not MB, not GB, KB of data to send the space people, Neil Armstrong and all, to moon. For that time, Mbps was the max speed, I guess. Even Mbps was considered too fast. These days, even terabytes won't fulfill our needs. 1980s, research relation prototypes evolved into commercial systems. SQL becomes industrial standard. Okay, so now we are getting serious. Parallel and distributed database system, object oriented database system. Okay, just like object oriented programming, we have object oriented database systems. In 1990s, large decision in supports data mining applications, large multi terabyte data warehouses. So like, okay, you have these supercomputers and all that start to become a reality. In early 2000s, we have XML and XQuery standards. Later in 2000s, we have giant data storages like Google Big Table, Yahoo Peanuts, Amazon, and all. Okay, this is the evolution, and evolution. This is a good table. there is no way that you can remember this table, but they have asked questions in activity regarding this table. So let's start solving the activity problems, right? Shall we? Which among the following statements is true? Four questions. Two major approaches in database management system practice have been physical and mechanical. Nope. Bookkeeping, bookkeeping from a data management perspective is the process of physical data or records management, physical ledger and journals. Okay, this might be right. No SQL was introduced since RDBMS. Not, I don't know about this line. One of the biggest disadvantage of electronic data management is that it might easily get destroyed by moisture. Nope, wrong line. Spreadsheet files are better than paper-based bookkeeping in terms of spreadsheets are better than paper-based bookkeeping in terms of. Let's go to that slide. I can, I remember the answers, but let's show you how we do this. So durability, there is less physical damage compared to book ledger. It is good. It is better in scalability. It can be password secured. There is better consistency. They are less prone to make mistakes than registers and easy to use. So I guess consistency, security, durability, and scalability. It surpasses bookkeeping in all the four aspects. Which of the following are disadvantages of file system as compared to this D.B.M.S? Okay, okay. I have to read the PPT for this, right? Disadvantages of file system as compared to D.B.M.S. As I said, each and every slide has ton of data. Like if you dive into each slide, you would be amazed how much data they give us, right? With Rapid, there has been considerable increase in time required to perform most operations. A typical spreadsheet file may have an upper limit. Okay, let me see. Well, as compared to DBMS, remember this line. As compared to DBMS, ensuring consistency of data, no means to check violation of constraint, unable to give different permissions to different people in centralized manner. A system crash would be catastrophic. This one is right. The constraint one, I guess, no means to check constraints, right? Uncheck constraint violations. Okay, I think this much was done. Which among the given options is correct option? Is the correct sequence of evolution of data management practices starting from the earliest progressing to the latest. Okay, okay, okay. So what came first and what came last? So parallel distributed, that is D.B.M.S, right? C came last or on came later on. Punch card for input, B came first, then hard disk came second, then parallel distributed came third, and data warehousing, like, this came last. Which of the following are client server RDBMS? As I said, you are not supposed to remember this, but there is a question in this, right? Which of the following are client server RDBMS, right? So this much, see, you need to remember this. I think if you remember only this much, right? This NoSQL part and its sisters: Cassandra, Couchbase, MongoDB, and Oracle NoSQL database. Once you remember this, you won't get much problem. So client server databases, Sybase is a client server database as shown here, the direct one, and I guess MySQL. Couch, is the MongoDB here? No. Is Couchbase here? No. Okay, what happened? What happened? What happened? Okay, no issues. Is PostgreSQL? No, PostgreSQL is not there. Is not there. Let's see how much did we go. Okay, 3.5. That's pretty good score. Let's see where did we lose 1.5 of our marks. Okay, so PostgreSQL is there, but where is it? PostgreSQL is this? So let's see. What is PostgreSQL? I just want to know the logo. This elephant one, right? Do you see some elephant logo? Mm-hmm, mm-hmm. I think they consider MySQL as PostgreSQL. I have absolutely no idea on this one. So let's skip this one for now and move up there. Upper limit on the number of, but okay, okay. Let's check it here. Um, no means to check violation of constraints. Okay, this is a different line, and the line in the question is different. Okay, with rapid there has been considerable. A typical spreadsheet file may have an upper limit on the number of rows. Upper limit on the, okay, so it usually has upper limit on the number of rows. Okay, five. And what is this? Unchecked constraint violations, right? Okay, okay. So I misread the line or misunderstood this line. Okay, so file systems cannot provide access to users, right? On different levels. But I misread the line and thought it was no, it was a negation. So let's forgive me for my mistake. Okay, let's go. Let's move forward. Let's remove the answers here. See, that's how we learn. That's how we learn. Even after doing it like two times before I am forgetting the answer. Let's remove this. Let's take it to A. Let's take it to A. No, I didn't. I did not want to check answers. I hope this. I hope this works. Okay, good. That's good enough. That's good enough. How many PPTs do we have for week? For lecture 3, 4, and 5. Okay, there aren't much. This these PPTs left. Let me invite people. Okay. Usually these meets are done in a Google Meet link, Gmeet link. But for these particular session, I have to repeat. As I have to repeat the session, I am doing it all alone. So where is it? Let's go to the slide. What does this module has? Evolution and history. Wait a second. Which one is this? Okay, it again will be telling us about evolution and history of record management. Okay. Case study of bank transaction. Case study of bank transaction. Okay. Okay. So this one doesn't have much to offer us. But let me quickly tell you what this this lecture would tell you. See, as in the Python section, you can see you have to write. This is file handling problem, right? In Python, this is file handling problem in Python. You have to write so many lines, and each and every function, each and every task has to be done explicitly. Whereas in SQL, it can be handled implicitly. See this, such a short, you know, such a small code. Let's go here, try for this. Okay, no issues. As we go further and further, you can understand. See, it's really easy to understand the SQL code. Begin setting amount, select balance from account. So there must be something called accounts. We are selecting balance from it, and into S balance we are checking the condition, and if the condition is satisfied, we raise the notice. So basically, this is error management or exception handling. Okay, comparison. See this one table is really important for this whole lecture. I will be going through each and every one of it, but let's wait for a few seconds, right? So the slides after that particular table are is the slides after that. You know, this table just contains in-depth explanation of each and every parameter, right? Parameterized comparison, right? So it would take the scalability parameter and compare Python file handling and D.B.M.S thoroughly. I don't think you need that much explanation, and I would invite you to read it on your own, as that won't help us with in this particular session. For this session, we only need this table. Okay, so let's compare. Comparison is a bad game, but we need to compare things. Scalability, very difficult in Python. File handling, I would be using file handling and Python synonymously, uh, whereas D.B.M.S has inbuilt feature to provide high scalability for a large number of records. Scalability with respect to changes in structure. Okay, so scalability with respect to amount of data. In Python, it is very difficult to handle insert, update, and query for large data, whereas it is comparatively easy in D.B.M.S. When it comes to structure, it is really the word they use superlative term. Extremely difficult to change the structure of a record, as it is as in case of adding or removing attributes. Adding or removing attributes can be seemingly simple. Okay, for those who don't know anything, let me just tell you, attributes are columns. Head attributes are columns. That's what they are. We call columns attributes, and rows tuple. Columns are called attributes and rows are called tuple. Tuple. This is something to remember. Time file handling takes mere seconds, whereas DBMS take milliseconds, which is even better. Going into persistence, data processed using temporary data structures have to be manually updated, whereas in DBMS, data persistence is ensured via automatic system-induced mechanisms. Robustness, ensuring robustness of data has to be done manually, whereas backup and recovery and restore need minimum manual intervention. Security, difficult to implement in Python. It is really hard to provide security at operating system level. Okay, whereas security in DBMS is user specific and gives us specific access or limited access to people, and gives even limited access to a particular table. Let's say let's say a person might not have access to all the tables, whereas let's say person A would not have access to all the tables, whereas person B has access to all the tables. But person A has access to each and every all the content in a table, whereas person B does not have access to every content in a table. Person A has access to this table and can see this as a whole, see this table as a whole, whereas person B might only be able to see this much section and not the column on the right, or the it would take two columns here from here and not the column on the left. That's how security works. Programmers' productivity. Most file access operations involve extensive coding. Okay, as we have seen, it needs you know real. It takes really long to code a specific problem. Standards and simple built-in queries reduce the effort in coding, thereby increasing a programmer's thorough throughput. Okay, throughput. That's a new word. Go to dictionary and find what this means. Uh, easy, easy to do arithmetic computations, and a limited arithmetic operations are available. Okay, so Python has one advantage: arithmetic computations or arithmetic problems are easily solved here. Cost. File handling has low cost for hardware, software, and human resources, whereas database has high cost for hardware, software, and human resources. Okay, let's solve this. Which of the following statement is true? File handling via Python takes less time as compared to D.B.M.S. That's a lie. It is easy to handle insert update query using Python. That's a lie. It is easy to do any set of arithmetic operations using D.B.M.S. than using Python. Nope. That's a lie. So it's none of the above. Which of the following statement is are true? Okay. In case of file handling via Python, it is difficult to detect and maintain relationship between entities if and when the attribute has to be removed. I guess this is true. In D.B.M.S, Turing relation constraints are used either not to allow the removal of attribute or to ensure safe removal. This line is hard to explain. The scalability of file handling using Python with respect to amount of data is higher than that. No, scalability is less. As we can see in the table, less scalability in both the points, whether we are seeing with respect to amount of data or with respect to the change in structure. I have some. This question seems shady, so I would only attempt, first with the first option, which I have 100% surety on. Okay. When we compare file handling via Python with modern DBMS in terms of time efficiency, which of the following statements is are true? Okay, the effort to okay, the SQL would take. SQL is database, right? SQL is a type of database management system. SQL would typically takes a few seconds. No, it would take milliseconds, whereas Python would take few seconds. In effort to install and configure database is expensive and time consuming. Yes, that is true. Cost is high. Cost is high. Initial cost and that initial setup is takes high maintenance and high cost. Which of the following statement is true regarding DBMS? The installation and maintenance are no wrong. It there is extensive support of arithmetic and logical operation. Yes, I guess, but no. I don't think this is right. Databases are inherently complex and need specialized people like database administrator to configure and maintain it. This is true. This is true. This statement is true. Explanation to explain that line, how did I know the answer to it? Because I read the PPT. You can find the answer in from slide number 17 to slide number 22. Read this once. Read these slides once. It would hardly take 5 minutes. Okay, it would hardly take 5 minutes. I did not go through all the slides because if I went through all the slides, you would have been confused because I was extremely confused. Consider the following statements. If we use Python for handling instead of DBMS, a programmer has to put in less effort into maintaining data. Nope. D.B.M.S has built-in mechanism to ensure the consistency and sanity of data. Statement 1 is wrong, but statement 2 is true. Let's check the answers. Okay, I would assume it the half marks that I lost was in question number 2. Let's jump to question number 2. Yes. So this is what I learned again. In D.B.M.S, during deletion and deletion constraints are used either not to allow the removal of an attribute, that is removal of a column, or to ensure safe removal. That is good. Hooray! We completed. We that 1.3 activity. Let's jump right to activity 1.4. Okay, so seeing the type of question, I can easily tell you this. This slide is important slide, right? Because this is introduction to database D.B.M.S. This is introduction to D.B.M.S, and they cover too much content in these three lectures. Let me see, was it three lectures or four lectures? I guess it was three lectures. Introduction to D.B.M.S 1 and 2. Okay, so I guess okay. Then there was introduction to relational model, introduction to SQL. Okay, introduction to SQL is different from introduction to D.B.M.S. Okay, no worries. Let's jump to this. What's happening? The fourth PPT. Module recap. Let's not go to module recap. What are the objectives of this PPT? To familiarize with basic notations and terminologies used in database management systems. The second one is to understand the role of data models and languages, and the third one is to understand the approach to design to database design. Okay, what are we going to study? Levels of abstraction, schema instance, data models, relational database, DDL, DML, SQL, LLL, database design. Okay, how many slides do we have? We have 25 slides. Let's start. Excuse me. I need a minute or so. Let's start a timer of a minute, right? I just need to drink water. Timer. Let's start 1.5. Oh, there's no way to. Okay, start. 1.5 minute timer. I'll be back. Privacy. Okay, I am back. Let me check this one thing. Hello. Okay, so let me check this one thing that I guess this is what it means. Once I take a break or mute this, does this actually get mute or not, or would I be embarrassed? Mute this, does this actually get mute or not? Hmm? Yes, yes. Okay. So where were we? My mother is asking me to change bulb. Sorry, I just need another minute. Let's start. Is it 1.3 or 1.4? Okay, it is 1.4. So three more things to do. So level of abstraction, right? So you can level of abstraction like this means how can you how can you describe something? How can you say something exists? So database or data exists in three levels. That is physical level, logical level, and view level, right? Physical level as in how the record is stored in database management system. Physical level means how the data is stored, where the data is stored. Let's say I make a table and name it instructor, so the physical level abstraction would be instructor. I stored the data in instructor. Logical data means describes the data that is stored in instructor, right? So as you can see here, type instructor equals to record. Now it has the following data. This is logical level abstraction. There are three string data types and a single integer data types: id, name, department name, a string, and salary is integer. View level, this is the final level of abstraction where application programs hide details of data types, right? So when you finally see the table, you won't be seeing, oh, id is string. They won't show it to you like that. They would show you the table. Let me see if the table is there or not. uh, mhm. This is view level, right? This is view level. View. I have to work on my pronunciation. View level. So this is the view of data. View level, logical level, and physical level. This is an architecture of database management system. Database system. Okay. Now view level can also hide data, right? It can also hide information such as an employee's salary for security purposes. Schema and instances. What is schema and what is an instance? Schema. Schema. What is schema? Schema is a heading. For any given column, schema is the heading. Let me show you this. Like if attribute is the column, if attribute is the column, let's say this much. Uh, there's no way to select it. Let me show you this. I think I have a data, right? I have a data set, present with me. This is not database man. This is not DBMS, but I guess you would understand it better if I show you this. Get stuff, get stuff done. Let's say this is my table, right? I have a table that here. Let me. So this is a column, this is a column, this is a column. The following all are columns, right? So we can call this singular column an attribute. This is L attribute, this is K attribute, this is G attribute, and all, right? But if you see at the very top, right? If you see at the top, this yellow portion, these have specific, criteria for the data stored below in the attribute. This is the heading. Like state is the heading, region type is heading, this response status is in heading. So for a particular attribute, this heading is called schema. The heading is called schema. Going back to where I was, I hope you understand what schema is. Hmm? Instance, right? This is the actual content of a database, right? Now in a column, everything except schema is at this an instance. Instance is basically the data that exists as a table, right? Once you start making the table, let's say hmm, after this, let me do this, right? This is an empty table, right? You have just the schema in it. You just have the schema in the table. But once you start inputting the data, this table has no meaning in itself if it does not have any instance. So if I add the data in it, these instances, these many instances, you get a proper table which has an actual meaning. So for a particular, let's say, attribute, this is a schema, this is a schema. Let me mark this. This is schema, this is schema, this is schema, this is schema. Everything except sorry, my mistake. This is instance, this is instance, this is instance, this is instance. Everything except schema is an instance. Okay. So let me mark the instance. In I guess blue color. Blue color would be good. Okay, now let's go a little lighter. See. So everything except the schema is an attribute. Array, what am I saying? Everything except a schema is an instance. Everything except a schema is an instance. Okay. Sorry for this blender. Physical data independence, the ability to modify the physical schema without changing the logical schema. Okay. Uh, there is a question on this. I would have to, make you. I will teach you. I would make you understand this concept when we are solving activity question. Okay. It would be better if we, see this slide or refer to this slide. Then data model. Let's go to data model, a collection of tools for describing data, data relationship, data semantics, data constraint. Uh, Most of the people understand what is data, what is data relationship, what are data constraint, but let's see what are data semantics, right? Because people won't understand the meaning of the word semantics. Let's add the word meaning, and by data semantics, that has been structured to add meaning to the data. Okay, structuring is semantics. Okay, entity relationship model, XML format. Okay, let's skip. As I said, just as I said, columns and rows. Columns are called attributes, and rows are called tuples. Tuple. These are some of the tables that you must see. These would be used many times in the coming slides, I guess. Instructor table, department table. Okay. Now let's dive into DDL and DML. So data definition language and data manipulation language. Once you have database management system, you need two types of languages. One is definition language, that is formation of the table. Once you have nothing here, you need something to form a table. So the DDL would be used to form the table. It would add the schema to the as the heading. Then you start how many this instances you can have. You would understand better if I teach you this. Okay. Specification notation for defining the database schema. Okay, so DDL basically works on schema on the heading. DDL compiler generates a set of table templates stored in a data dictionary. Data dictionary contains metadata. Okay, this is an important line. Data dictionary contains metadata, that is data about data. Okay, this line, let me explain this line better, right? Data about data. So I have this data. Now data about data would mean, okay, this this is a string value. This is an integer value. Not this is an integer value. This might come as varchar. Okay, that is the meaning of data about data. See this is data about data. ID is the data, and char is specifying. Char explains that ID schema must contain or can contain 5 character type data at max. Name can have variable character data, with 20 being the limit. Same with department name, and let I would be explaining this numeric later on. Numeric is something you would see or understand once you see. Okay, numeric is something you would understand once you see. Now, what is data manipulation language? Language for accessing, manipulating the data. So once you have formed the table, you need to add instances, add information, add data to the table. You use DML then. DML is primarily known as query language. Two classes of this language. The one is pure, used for computational power and optimization, used by scientists and researchers, whereas commercial one being used into companies or large enterprises. SQL. Okay, what is SQL? The most widely used commercial DML and DDL language. SQL is not Turing machine equivalent language. That is, it cannot solve all problems that higher level programming language like C or Python can, but can solve problems regarding a database system or a database table. To be able to compute complex functioning, SQL is embedded in some higher level language. Okay, so you have to connect a higher level language such as Python with this SQL. Application programs generally access database through one of the following language extension to allow embedded SQL. Okay, let's move forward. Let's move forward. What is database design? What is database design? The process of designing the general structure of a data. Logical design, deciding on a database schema. The database design requires that we find a good collection of relational schema. Physical design requires deciding on the physical layout of the database. Okay, data design one. Let's move to this. Right. Let's move to the questions. We have 12 questions to go through. Let's see what these questions are. Hmm. Uh, a database management is conceptualized in terms of 3 levels of abstraction. Which of the following is not one amongst this? Application level. We saw physical level, we saw logical level, we saw view level, but not application level. Which of the following levels describe how the data record, how the records are actually stored. So which of the following would tell you about it? It would be physical level, as I said it. Where and how is it stored? As in instructor, how the table is stored in instructor data set, right? That one. Which of the following level describes the relationship between data in data base system? That is logical level, I guess. Logical level or view level? I guess this one would be view level. Mm-hmm. Schema instances. Uh-huh. Okay, it comes later on. Where is it? I think I'm scrolling too fast. Let's see. Okay, view level. Applicator hides the detail. Okay, records shows the relationship amongst the data fields. Okay, so that is logical level. Shows relationship between the data among the data fields, but this is between data. I think this one might be incorrect, but let's move forward and come to this later on. At dash, application programs may hide certain info. Oh, that is definitely view level. That is definitely view level. A and describes how. Okay, dash describes how the data is organized in a table. Okay, that is schema. Which of the following languages defines and manipulates data? uh, Defines and manipulates. Okay, the schema. Okay, so when we are working on schema, that is defining the table itself, so that would be DDL, data definition language. While because this is used while making the data. Which of the following languages can be used to create new records and manipulate existing records? Right, that would be data manipulation language. Which of the following is are true about schemas in database systems? Right, which of the following is are true about schemas in database system? It describes overall structure of the database system. Okay, it is actual content. Nope. Is similar to the type of information of variable, I guess. It is similar to the value of variable. No. Let's move forward. Which Why did I select this? Okay. Which of the following is true about the instances in database system? It describes the overall structure of the database system. True about the instances, right? So it does not do that. It is the actual content of the database. Yes, it is the actual content. It is similar to the value of variable in programming languages. It is not similar to the type of information. Okay. Which of the following is are the content of a data dictionary? What are the contents of data dictionary? I guess we read about data dictionary somewhere here. If we are lucky enough, we would be able to find it, using control F. Data, I guess data dictionary. Data dictionary contains metadata, that would be schema, integrity constraints such as primary key and such, and authorization. Okay, so schema, integrity constraints, and authorizations. Good. Which of the following decisions is our part of logical design of? Okay, let's see. Which of the following decisions is are a part of logical design of a database? Logical design, logical design. Deciding on database schema. Database design requires that we find a good collection of relational schema. Okay. Uh, should fulfill. How should a database be structured to fulfill business requirement? What attributes to be recorded in database? And what relations should we have to? Mhm, we have, and how the attribute to be distributed among, how the attribute to be distributed amongst the collection of schema. What should be the physical layout? Is there something here about physical layout? No, there is nothing about physical layout. How should structured should have physical layout? Okay, let's move forward. Which of the following decision is our part of? Is our part of physical design of database, right? Physical design of database. Wait a second, is just the same question? Okay, this is physical design, that was logical design. Deciding the physical layout. Is there a problem with relation? Okay, I think that one is. Uh, can be distributed. How? What are the attributes to be recorded? Right? What are the attributes to be recorded? I guess that is what are structured to fulfill the business requirement. What should be the physical layout of the database? I guess that is the answer. Let's see. कितने तीर मारे? We are at 11.67. Okay, that is a really good score. What are the attributes to be recorded, right? What are the attributes to be recorded? How should the database be structured to fulfill business requirements? So we missed out on one. Okay, okay, okay. Wait a second. Okay. So let's move to 1.5, right? The last PPT. 1.5 being the last PPT. Let's move to 1.5. Introduction to D.B.M.S 2. Okay. Module recap, module objective. What is the objective of this module? Okay. Mm-hmm. So let's familiarize with some more concepts of D.B.M.S, XML, and this database engine being primary objectives of the PPT. Okay, array, no issue. Data design. Okay, so we need to again see data design. Design approach. Let's jump right into design approach. No need to come up with methodology to ensure that each relation in the database is good. Okay, let's see the definition of object relational data models, right? Oh, these are a combination of object oriented database models and relational models. So it supports objects class inheritance. Okay, just like object oriented modules and has support for data types, structural, tabular. Let's see a picture on this, an image, I mean. So these are the schema and these are object 2 schema. Let's move further. Okay, let's move further. XML, extensible markup language. It is defined by WWW consortium, that is W that W3C consortium. It was originally intended as document markup language and not a database language. And the ability to specify new tags and create nested tags structures made XML a great way to exchange data, not just documents. XML has become a basis for all new generation data interchange formats. A wide variety of tools is available for parsing, browsing, querying through XML documents. Database engine that is, every system, every machine has an engine or a driving structure. In DBMS it is database engine. It is made of three major parts: storage manager, query processing, and transaction manager. Storage manager, it is the program module that provides the interface between low level data stored in the database and the application program and the query submitted. Okay, so let's say this is the low level data, right? This is the primary data or the very raw data that exists. Now storage manager is an interface between that data and the queries that is submitted to the system, right? So let's say I gave a query to remove this column power. What is this? Power group. Let's remove the column power group. Okay, and it is thus removed. See, it is basically empty. Let me just expand this here, right? This is an empty attribute now. So it works as an interface between this command that I put in and the data that already exists. But obviously, it has some issues that as storage access, file organization, index, and hashing. Okay, the storage manager is responsible to the following tasks: interaction with the OS file manager, efficient storing and retrieving of updating of data. What is query processing? Okay, so this is something important, right? You need to understand this one. Let me once check again if the live stream is going smoothly or not. It would just take a minute. Has some issues that storage access, file organization. Okay. The storage manager is responsible for the following tasks: interaction with the OS file manager, efficient storing and retrieving, updating of data. What is query processing? So this is okay. So the live stream is going pretty smoothly. Let's begin. So query is basically that DML, data manipulation language. Once a query is submitted, let's say I submit a query regarding this to remove this power group. What would happen is the query would first get translated through the translator into a relational algebra expression, right? Something like plus minus stuff. Okay, then it would go through the optimizer into the execution plan, and the data here would be evaluated through the evaluation engine. Once evaluate, let's say I wanted to delete this I data, right? So what would happen is it would go from A to B, 3, 4 to P to F to G to H to I, right? Once it reaches I, it would just delete. Let me, yes, it would just delete the data. Hmm. That's how a query is processed. That's what query processing is. Mhm. There are many ways to evaluate a particular given query. So let's do transaction management first, right? What if system fails, right? Transaction is a collection of operation that performs a single logical function in a database application, right? It ensures that the database remains in a consistent state despite system failures, right? Like power failures or operating system crashes. The concurrency control manager controls the interaction among the concurrent transaction to ensure the consistency of the database system internals. If you want, you can go through this. Sir, do recommends to go through this? If you don't, that won't affect your quiz grades, but this would highly enhance your understanding of the subject. Let's go here. Database architecture. The architecture of a database system is greatly influenced by the underlying computer system on which the database is running. Okay, so is it centralized? Is it client server? Is it parallel? Is it distributed? Is it cloud? I think most of us are aware of this cloud one. Amazon cloud, Apple cloud, all of the various cloud services that exists. Okay, let's quickly move on to this activity 1.5. Okay. Mm-hmm. Well, I did a mistake now. I should have removed the options beforehand. Still, we can go through it. Still, we can go through it. Okay. Which of the following is are true about object relational data model? It has atomic values. It provides upward compatibility with existing relational level languages. And that means it can be it can be used along with higher languages such as C, Python, Java, etc. It allows attributes of tuple to have complex data types. That is even true. Let's see this once here, right? So allows attributes to have complex types, provides upwards compatibility with existing languages, extends the relational model by including object orientation, and constructs to deal with added data types. Okay. Dash controls the interaction amongst the concurrent transaction in order to ensure. Okay, before we do this, let's not make a mistake here. Let me remove each and every one of this answer because there is no PPT for this practice assignment, right? Let me remove all the answers here. Okay, so we're done with this. Let's save the answers. So when we return, it has the same answers and not has correct answers that I gave in input. Let's see some some lines that are true about XML. All of the above. So yes, it was defined by WWW consortium, W3 consortium. It, its ability to specify new tags and create nested structure made XML a great way to exchange data. A wide variety of tools are available for parsing, browsing, and querying XML data. XML data and documents. Okay, it was all of the above. Dash is a program module that provides interface between low level and high level. That is storage manager. We just saw it here. Hmm. Provides the interface between low level and high level data array. Which of the following is true for entity relationship model? It is associated with a diagrammatic representation known as ER diagram. We have to see that one. It models a real world enterprise into collection of entities and relationship. Okay, ER model. Let's go to entity relationship. Mhm, mhm. Entity entity relationship model. So there are okay. So data design approaches. It was in the design approaches. There are two ways of doing design approach. One is entity relationship model, and the other is normalization theory. Okay, in an entity relationship model, it models an enterprise as a collection of entities and relationship, and it models something and is represented diagrammatically by ER diagram. Okay, normalization theory formalize what designs are bad and test for them. Since we know the answer, let's skip. Which of the following is true for normalization theory? It tries to formalize and evaluate a design for good and bad, and also tests the quality of the design. Okay, let's check answer. Obviously, it's 7 on 7. Let's go to practice assignment, right? Let's go to practice assignment now. Let me get rid of polyphony. Okay, take a break of a minute. Okay, let's start a break of another minute. It's here on my mobile phone. I would ask you to do the same. This is the final part of the video. This is the final part of the video. So that's a minute. Let's start. Uh, I have already done, the GA, and I would like to, invite you people to our GA solving sessions. But it's better that you do it on your own and see the answers on your own. Just a minute. That was a good water break. Let's start. Okay. A programmer is working on a data structure that stores data internally in a database, right? Okay. At what level of abstraction is the programmer working? He's working on physical level, because working on the data that is stores data internally in a database, right? How and where the data is stored. From among the following given types of application, choose the ones for which D.B.M.S will be preferred choice over file systems. Okay. Okay, with a large data set, obviously, with the concurrent transactions, obviously, with no dedicated database administrator. No, you need dedicated database administrators. That is a false statement. Do remember that you need specific database administrator to work on D.B.M.S. By the concept of logical data independence, the change made in logical level should not affect the which of the other levels of abstraction. So always remember, it is always physical level, then logical level, then this upper what is view level, right? So do remember, uh, the changes made in any lower level would not affect any of the upper level. So it is physical logical view. Any changes made in physical level won't make a change in logical level, won't make any change in view level. So it's if change is made in logical level, it won't affect view level. By the concept of physical data independence, a change in physical data should not affect both logical and view level. Which of the following is widely used during the planning and designing of the database? Entity relationship model, highly used. Is it so? Hmm. See, widely used during planning and designing. During planning and designing, I guess it is entity relationship model. If it's wrong, we would change the answer, obviously. Which of the following are the advantages of D.B.M.S over file based? Okay, okay, okay. File based data management system. I did not read the word file. Okay. Consistency of data, efficiency of operation. Obviously, initial setup is really hard and costly. So that is not the answer. And recovery of data is a point that I am not completely sure on. Which of the four? Let's see. Right, we can go there. Right, we can go there. Mhm. In Y database, right? See, as I said, this table is really helpful. What was this? Easy recovery of data. I don't know. Is there something about recovery given here? Persistence manually updated? No. Okay, see this. Ensuring robustness has to be done manually, but the word recovery is used here. Backup, recovery, and restore needs minimum manual intervention. Okay, so I guess D.B.M.S rocks in recovery of data. Which of the following is good option for exchanging data among different systems over the internet? I guess SQL or MS Access. I would go with MS Access because XML is something totally different. SQL is DDL, DML stuff. HTML has not been mentioned in the PPT anywhere. I guess it is MS Access. So we are going through the process of elimination here. Planning what attributes should be placed in which table of a database is a part of which attributes to be placed in which table. That is physical design. it was shown in the very first slide where the physical level was defined by instructor, right? Which of the following options are example of data transaction? Which of the following options are example of data transaction? Transferring funds, okay. Booking, reservation, in increasing, updating KYC. I guess these three. Which of the following model aptly satisfies the need for a system which maintains large set of complex interconnected data where the semantics of interconnection changes dynamically, like a social networking site? XML data or relational model? XML or relational? Let's check the answer and we'll find it on our own. Right. So it is graph model. Okay. Something new. Something new. Let's go to the last PPT. It would be definitely in the last PPT. Where else can it be? So let's see. GRAPH graph. Okay, there is nothing. Okay. F GRAPH. Not, no mention of graph again here. Control F. GRAPH. No mention of graph. I don't think there is. Control F. GRAPH. Okay, so this is something new that we have to remember. Okay, 7 out of 10 is still good, but it would be better if I can, score a 10 on 10. Okay, so one mistake that I did was planning and what attribute should be placed in which table of a database is a part of. Okay, so the columns should be placed in which of the table is a logical design. Okay, and which among the following is good option for exchanging data among the different system over the internet? It is XML. Okay, so let's go to XML. Mm-hmm, mm-hmm, mm-hmm. Did I just see XML or not? Relation XML, right? Okay, it is not mentioned here, I guess. Mm-hmm. So, okay, new data. Remember this seventh one. Okay, the last error that I did. Where is the error? There has to be an error. This XML one, this logical one. Okay, so I have covered all of it. Voila! Congratulations, we completed week one. All the activity questions and the practice assignment that is provided. I, thank you for bearing me for how much? How long? Let me see. Is the time for an hour and almost 2 hours. Okay, thanks for bearing me for almost 2 hours. I can guarantee you that once you watch this lecture, you won't need to revisit the chapter or the week ever again. I thank you for joining this session and watching this video. And this is my first time ever saying this. Like, share, and subscribe. Bye bye. Let's end this stream. Bye bye.